Hey, how's it going? Welcome to Freeburg's Free Advice, another math edition. We're going to take a look at how to take rational functions and divide them and simplify them using long division and synthetic division. So we're going to start with long division because long division is going to work for any type of division, whether this base number down here is a linear function, just like it is now, or if it's a quadratic or a cubic or anything really, you can go ahead and do long division to actually help you divide two rational functions. So here we're going to take a look at long division. It's very, very similar actually to what you've probably done way back when you're just doing long division of numbers. So let's get a little bigger pen here. So let's say we've got our 3x cubed plus the 7x squared minus 2x minus 6. And we want to divide it. So long division, this is going to be, again, it's even going to look like the old school long division used to look with numbers. But the only difference is now you're going to take your lead term here, so in this case x, and you're going to divide it into the first term here. So how many times does x go into 3x cubed? Well, it goes in there 3x squared times. Okay, so I like to keep my powers of terms kind of over the top of each other. And then what we're going to do, just like you did with long division, I'm going to take that number and I'm going to multiply it by this to figure out, well, when I actually did that, what happened. So I end up with my 3x cubed plus 3x squared. And then just like long division from back in the day, you're going to take that and you're going to subtract it. So I end up with 0, which is what we were hoping for. 0. And then when I pull 7x squared minus 3x squared, we're going to see that there are 4x squared left. Well, then we're going to basically repeat this pattern. So how many times does x go into 4x squared? And hold on, one of the steps I forgot there. Just like long division also, we're going to bring down that next term. So we got this minus 2x. Okay. So as we do this, x goes into 4x squared 4x times. So positive 4x times. We'll repeat these steps. Take that, multiply it by that, and so we'll see that this ends up being 4x squared, like we'd hoped, plus 4x. And again, we're going to subtract that line from it. So there's our 0 we're hoping for. Negative 2x minus 4 more gives us a negative 6x. And so we see here, let's bring down that next term, minus 6. We'll repeat this step one last time. So how many times does x go into negative 6x? Well, it goes in a negative 6 times. And then let's see if there's any sort of remainder. So we'll take that, multiply by that, and we see that we end up with negative 6x and minus 6. Well, when I subtract that line, negative 6 minus a negative 6 is like adding, so there's a 0. And negative 6 minus a negative 6, there's a 0. So actually, I have no remainder here, so that's nice. This actually synthetic or long divides perfectly. So if I were to rewrite that function now, we can actually see that we can write this function as x plus 1 times 3x squared plus 4x minus 6 with no remainder. So there's my new, I'm basically able to factor it using long division, and I come up with that number. So that's super helpful and nice, because now we're left with a quadratic, which, you know, maybe that's factorable, which actually it is, yeah. So if we wanted to factor this all the way out in the linear terms, we now have that piece left over. And if you are struggling with factoring, go back and take a look at the quadratic one I've posted, and you can see how to factor that remaining piece. But our AC is negative 18 and our B is 4, so we see that we could do a positive 6 Negative 3? Nope. I don't know. That might be factorable. If it's not, it's at least a quadratic, in which case you can go ahead and throw it into the quadratic formula. So that's not what's being asked right now, so let's not worry about that. Let's see, could we do this with synthetic division, and do we get the same answer? Well, hopefully we're going to get the same answer, right? But synthetic division is only going to work, it's a nice little trick, only if that divisor is a linear term. So in this case, if we think about kind of that zero product property, we'd see that x equals -1 would create that 0, right? Well, synthetic division is this idea that I'm going to take some x value and see if it goes in perfectly or not. So I've always been taught, go ahead, take your x value, put it inside this little box. And then we're going to write our equation without any of the variables. So I'm going to have a 3, and a 7, and a -2, and a -6. If I'm missing a term, you basically have 0 of those. So make sure you remember to hold it with a placeholder of 0. So the first step in synthetic division is we just bring down that first, so 3. And then the pattern here is we're going to take that number and we're going to multiply it by that number, okay? And then we're going to take that result and move it up into this box. So we're going to see that -1 times 3 is -3. Well, then what we're going to do is we're going to add this column. Okay, so here we're going to see we end up with a +4. And then we just repeat this pattern, right? So we've got this -1 times, okay, this 4, which gives us a -4. And then we're going to add the column, which gives us -6. And then we're going to multiply my x value times that value, which gives us a +6. And then we're going to add this column. So that gives us a 0. Well, that's our remainder, which we saw. And then these values are in order. So this is basically, this is basically x to the 0 power, x to the first, x squared, and so on. So if you add more values, you just keep going on. So what that allows us to see is, again, I have this x plus 1, and then I factored that out, and our remainder here is now 3x squared plus 4x minus 6, because x to the 0 power is just 1, so that's why we don't see. So again, we get that exact same value with a remainder of 0, so it factors out perfectly. So that's how you can use long division and synthetic division to help you divide out rational functions. So thank you for watching Freeburg's Free Advice. Enjoy the rest of your day.